Welcome to today's video where we're going to go through how to switch quadratic functions between vertex form and standard form. Alright, so let's get to our smartboard slides here. Okay, so vertex form was studied in our last video, and that would be this format right here. So that's where we have our stretch factor, our coordinates of our vertex. Sometimes you'll see H and K used here, P and Q. Doesn't really matter, it's all interchangeable. It's just a matter of knowing when numbers are in certain locations what their effect will be. Standard form of a quadratic function will resemble this instead. So it's going to be ax squared plus bx plus c, where it's basically this expanded out and all collected into with all the like terms. Okay, so looking at, just want to hide this. Just want to switch here for a second to my here. There we are. And now, what we need to be able to do is, if we're presented in standard form, change it to vertex form. If we're presented a vertex form of a quadratic, well, there may be some reason we want to switch it to standard form. This one is the most commonly used one, just because you can get a lot more information out of it. However, this one is sometimes used. There is a couple of things you can get very quickly from it. But the key is to learn processes that allow us to switch between the two. Okay, so let's first, just kind of as a precursor, make sure we remember how to expand a binomial. And this is a very common thing that sometimes students will mess up a little bit. So if I just take here x plus 3 squared, well, I'll just show you, hopefully you realize what that means. That means x plus 3, right? It means to take x plus 3 and multiply it by itself. Well, to do that, it would be x multiplied by x, that's x squared. X times 3, that's 3x. 3 times x, that's another 3x. 3 multiplied by 3, that's 9. Collect your two like terms here in the middle, and that would give you x squared plus 6x plus 9. Now, by the time we get to pre-calculus 11, though, we like to encourage our students to do this a little bit quicker and be able to skip this, and go right to here. And there's a little shortcut that sometimes you'll hear me refer to it as the 3-step rule. I'll say, don't forget your 3-step rule. And what I mean is, there's a shortcut that'll allow you to take a binomial, so two terms, being squared, only works for squared, and quickly go right to your answer. And the steps are square the first term, multiply the two terms together and double the result, and then square the last term. So if I just go back to the one that I did and use that as my model, square the first term. Well, the first term is x, so when you square x, that's where I get x squared. There's step 1. I'll number them underneath here. There's step 1. Multiply the two terms together. So x times a positive 3 would be 3x, and then double it. There's your positive 6x. That's step 2. Square the last term. Positive 3 squared is a positive 9. There's 3 steps. Step 1, step 2, step 3. So let's try that with these other 3 binomials where we simply go right to the answer. We don't show any work. We just use the shortcut to 3 steps. Alright, so here's the first term, and positive 7 is the second term. Square the first. Multiply these two together, so x multiplied by 7 would be positive 7x. Double it. Positive 14x. Square this last one. Positive 49. See how easy that is? Alright, a couple more. So it doesn't matter whether it's subtraction, this time it's subtraction in the middle. You do have to pay attention to it though, so watch how it's going to be a little bit different. Square the first, no problem, x squared. This one multiplied by this one will this time be negative 9x. Double it, negative 18x. Sometimes students will carelessly get these signs wrong. Square the last one. Negative 9 squared. Well, negative 9 times negative 9 is a positive 81. This first one and last one in the three-step rule, they're always going to be positive because whatever's here, you're squaring it. And if you take any number and you square it, whether it's positive or negative, or any variable, whether it's positive or negative, and you square it, it turns positive. All right, one more just to reinforce, make sure we got this down. So it's 3x, we're going to square the first. You're going to square the 3 and the x, so you're going to get 9x squared. Multiply these two together. I'm going to get negative 15xy. Double it. Negative 30xy. Square the last one. Plus 25y squared. Square the first. Multiply these two together and double. Square the last one. It's funny how you remember things. I can remember when I was in grade 11, my teacher, Mr. Shannon, kind of as a way for us to try and remember this, he'd say multiply these two together and then times by 2. Multiply these two together and then times by the 2 that's up here. That's how you get your middle term. So maybe that'll help you not to forget that double part on the middle. Alright, so let's start with if it's in vertex form and we wanted to put it in standard form. So something like this, that's in vertex form. So I can tell from this that it has a vertex of 1 and 5. It opens up because it's positive. It's got a stretch factor of 3, which would make it a little narrower than y equals x squared. So that's all information we did in our first video when we did our properties of quadratic functions. So now what I want to do is change this to standard form. Now remember what that is. Standard form is ax squared plus bx plus c. So what it wants you to do is basically expand this out. Well, that's why I just reviewed with you how to square binomials, and I did 4 examples of it. And like order of operations, you can't, a common mistake is students will bring the 3 in and then square. Well, I want you to think about what you're doing. That would mean you're multiplying by 3 and then doing exponents. That means you're doing order of operations in the wrong order. You have to do the exponent first, then you can multiply by the 3. Alright, so here we go. Leave the 3. Square this binomial. 3 steps. Square the first, multiply and double, square the last. Just leave your plus 5 for now. Now you're going to multiply by 3. So y will equal 3x squared. Subtract 6x plus 3 plus 5. And then we'll collect these two together. Y equals 3x squared. Take away 6x plus 8. So now it's in this form. ax squared plus bx plus c. Y equals. The only real advantage to this one is it really lets you figure out the y-intercept very quickly. You say, what do you mean? Well, if I said to you, what's the y-intercept here? Well, what you'd have to do is take x equals 0 and fill it in here. So you'd get 0, take away 1, negative 1. Square it, you'd get 1. Times 3, you'd get 3. Add 5, you'd get 8. So the y-intercept is 0, 8. Now you still do the same thing here, but in this format, if you fill in x as 0, it's going to make this term become 0. It's going to make this term become 0, and every single time, the number at the end will be your y-intercept. So that's the one advantage to standard form, is that you can very quickly identify the y-intercept. It's always going to be that last term, because these two are going to automatically become 0 by us letting x be 0. Alright, here's another one. Back to blue here. So y equals negative 2. Square the first. Multiply and double. Square the last. Still got my minus 10. Minus 2x squared. Now I'm distributing the negative 2 into the bracket. So negative 16x. Negative 32. Take away 10. And collect your two numbers at the end. And there you have it in standard form. So there's really not much to that other than making sure you know how to square a binomial, and then just make sure you do your exponent where you square first, then distribute your coefficient through, then collect your like terms. Alright, so that's going from vertex to standard. That's the easy one. The one that's a bit more challenging is to go from standard form and turn it into vertex form, which is going to be the one we're going to need to do more often, because I think you've realized that finding the vertex of a quadratic is always going to be a very important point to know, depending on what you want to do with it, but it's a critical value in the study of a quadratic function. All right, to do that, I want us to look at what exactly is a perfect square trinomial. Here's a couple of examples of this. So if you took this and squared it, you'd get this. If you took this one and squared it, you'd get this. So essentially what we need to be able to do is, if I have this, how can I turn it into that? Well, I can't do that unless I identify a pattern here. Well, in order for it to be a perfect square trinomial, the first term and last term must be perfect squares. Just want to double check something here. Yeah. Okay. Oh, there, the piece was missing. That was the problem. So yeah, as I was saying, the first and last terms have to be of the form a squared and b squared. Just means perfect square. So if you look at this one, x squared, if I said to you, is that a perfect square? Hopefully you'd say, yeah, it is. The square root of it is just x. I'm just going to not put it up above here. The last term, plus 25, is also a perfect square. Its square root is 5. Now the middle term can't just randomly be any number. It must be these two square roots multiplied together and doubled. Now it could be positive or negative, that does not matter. The middle term. First and last term have to be positive, because if they're not positive, they're not perfect squares. But the middle one can be either positive or negative. So if I check this one, I'd say, well, x times 5 is 5x, doubled is 10x. So 5 times x times 2, yes, this is a perfect square trinomial. Let's check this one. So if I check this one, I've got square root of the first, that's a perfect square, that's a perfect square, multiply them and double them, you're going to get 16. Again, we don't care whether the middle one is positive or negative. That one works. So it says here, write out any 3 other examples. You could make your own. Make up your own perfect square trinomials. So if you're watching the video, maybe pause it for a second and see if you can write out 1 or 2 examples of what you think would be a perfect square trinomial. Alright, so I'm going to do a couple here. So I'm going to go with, I'll go with x squared again. Now often this one's easiest to just kind of go to your last term before you make your middle one. Then I'll put a plus maybe 49 at the end, which means the middle term's going to have to be, so this is a 7, the square root of it, this is x, multiply them and double, I need this to be a 14, and it can be plus or minus. Now don't forget the variable in the middle term is always the square root of these as well, so 14x. That's a perfect square trinomial. Here's another one. I'm going to actually put a coefficient in front of it this time. Let's go with 9w squared and a plus, let's just put a 1 there. That's a perfect square. So what's the square root of this one? It's 3w. The square root of this one is 1. Multiply those two together, you're going to get 3w. Double it, it should be a 6w here, either a positive or a negative. And finally, let's do one more. I don't know, let's put 2 variables in this one. So let's go with 25. I'll go with a squared. At the end, I'm going to put 16b squared. So this time now, the square root of this one will be 5a. The square root of this one will be 4b. So when I multiply 5a and 4b, that's 20ab. Double it, I need a 40ab here in the middle, either positive or negative. So I'm going to put negative 40ab to 4. Alright, so that's the first thing, being able to identify the pattern. So then what I want you to be able to do is undo the pattern. How do I factor and get it back to look like this? So to do that, what we're going to do, switch the colors here. So it's going to be a trinomial, and we're going to follow this pattern. We're going to take the square root of the first term, the sine of the middle term, and the square root of the last term. And we're going to put it in brackets, and we're going to square. So let me say that again. Square root of the first term, sine of the middle term, square root of your third term, put it in brackets, squared. Quick and easy. Now again, you have to make sure you've checked that the pattern has held true. You took the square root of this one, the square root of this one, you multiplied and double, you got this one. Once you realize that that's the pattern, then it is square root of the first one, sine of the middle one, square root of your third term, in brackets, squared. Square root of the first term, 5a, sine of the middle one, square root of your last term, in brackets, squared. That's going to be important that you realize that pattern and how to, because we're going to, the process I'm going to show you is going to be called completing the square. We're going to build perfect square trinomials. So once we build them, we need to know how to factor them then. Okay, so here's 4 perfect square trinomials. This would be a good point for you to pause the video, write these out, and when you're done, check your answers real quick to see if you've got this down. So I'm just going to answer these now real quick here. So square root of the first, sine of the middle, square root of the last one, all squared. The square root of this was x, square root of this was 25, multiply double, you got your 10. X, 3, multiply double, you get a 6, good to go. Square root of the first, sine of the middle, square root of the last one, all squared. 6x and 7, 6 times 7 is 42, double it, 84, we're good. 6x minus 7 in brackets squared. 81x squared is 9x, 4y squared is 2y, 9 times 2 is 18, doubled is 36, we're good. 9x, sine of the middle, square root of this one, 2y, all in brackets squared. Alright, so that's a skill you need to make sure you have. Probably under normal conditions you should have seen that in grade 10, but if you haven't, that's okay. The last couple slides should be able to get you back up to speed. Just looking quickly at the 2 forms before we get into more detail into how to switch them. So in this form, your stretch factor is still going to be the number in front of your x squared. The c value becomes your y-intercept. This will also tell you whether it opens up or down. So for example, if I said here, y equals negative 3x squared plus 2x minus 7. This is what you could tell me from looking at this. It opens down. It has a stretch factor of 3, meaning from the vertex, if you go 1 right or 1 left, it should move down 3 units on your scale. And I know that the y-intercept of this function would be a minus 7. The one important thing I can't see from this is I do not know what the vertex is. And that's a critical value to know for a quadratic. Versus this one, you'll see I can get a lot more out of this one. So for example, if I had y equals 2x plus 5 squared minus 4. Well, let's identify what I can see out of this one. I know that it opens up. I know that it has a stretch factor of 2 over 1 up 2 over 1 up 2. I know the vertex is negative 5 and negative 4. I know the axis of symmetry is x equals negative 5. I know the graph represents a minimum because it opens up. I could have told that over here as well, I guess. And it's real quick and easy to draw a sketch from this method because I just put my vertex on and then I go left 1 up 2, right 1 up 2, draw your parabola through those points. We did that again in the last video lesson. Therefore, it's going to be important that if I had this, I want to be able to know how can I take this form and turn it into this form. So that's what I'm going to show you how to do. That's kind of the essence of this lesson that we pick up on, a method called completing the square. Okay, so here we go. So we want to go from standard form to vertex form. Let's look at these first 3. And let's suppose I wanted to make a perfect square trinomial. So you're going to look at this and tell me, well, what number would I have to put in here to make this into a perfect square trinomial? Well, in order for this to be a 10, this is an x squared, this is going to have to be a 25. You say, well, how do you know that? Because if I took the square root of 25 and the square root of x squared, that'd be 5, that'd be x, and I multiply them and double them, I'll get 10. So in order for this to work out, this is going to have to be a 36. Well, let's go up here. So then to factor that, it would be x plus 5 in brackets squared. Square root of this is 6. The square root of this is x. Multiply and double, you get your 12. So it's x take away 6 squared. This one's a little tougher. It's going to be 25 over 4. Now you may be thinking or saying, 25 over 4, where are you getting that? You might have said the decimal version of it. Anytime these, when you go to, let me back up to a second to these two easier ones first. If I was looking for a shortcut to say, well, how do you get that number? Is there a plan? Like, is there steps that you can do, or do you just got to kind of think it out in your head? Well, there is actually a nice little method that works. If you took half of this number, which would be 5, and square it. Take half of this number and square it. That works every time. Take half of this number. Well, half of 5, a lot of times I find students when we're in class, they right away say, oh, it's 2.5. And they're right. But it's much easier to do this if you keep it in fraction form. One of the goals of pre-calculus is we try to move away from calculators as much as possible. We try and do as much of the mental math part as we can in our heads, because a lot of the introductory calculus programs beyond high school, they don't allow calculators at all. They just want students to be able to work on these types of calculations without relying on a calculator. And I know for some of you that's a big issue in pre-calc 11. It gets better as you work toward it. So half of 5, an easier way to think about it is just like this. That's half of 5, 5 over 2. Well, then to square that, you just square the numerator and you square the denominator. So that would become 25 over 4. Square root of the first, sine of the middle, square root of this one. So if it's a fraction, you just take the square root of the numerator, square root of the denominator. So that would become 5 over 2. And let's try another one like that. Take half of 7. Half of 7. If it doesn't go evenly, just put 7 over 2. Square 7 over 2. 49 over 4. Square root of the first, sine of the middle, square root of the last one. Alright, so let's say the middle term is already a fraction. Take half of 3/4. I'll put it over here so we can see better. Half of 3/4. Well, of means in math to multiply. So half of 3/4 is 3/8. There's half the middle coefficient. Square it. Square the numerator, square the denominator. So this would become 9 over 64. Take the square root of the first term, sine of the middle term, square root of this one, in brackets squared. So what I've been doing here is a method or a strategy called completing the square. And basically completing the square is this. Take half of your middle coefficient, the number in front of the x, and then square it. That's how you complete the square. Now, in order for that to work though, if you notice my examples, it only works because I had a 1x squared here. So eventually we're going to have numbers in front of x squareds, and we'll talk about it when we get to it, but we're going to have to do a little bit of extra work to make sure we're only ever completing the square when I've got 1x squared as my coefficient. Alright, here we go. Into how does this play into quadratic. So let's suppose I've got quadratics in standard form, like these two, but I'd rather they be in vertex form. So these two start out nice and easy because they already have the 1x squared in front of it. Well, this is what we're going to do. So we're going to go y equals x squared, subtract 6x. We're always going to put a plus sign because we're going to make a perfect square trinomial. This has to be positive. And you're going to leave a blank here. and you're going to close that bracket off. Then you're going to put your plus 4 back here. So at this point, this is no different than this line up here, other than I put a plus sign and left some room here. So now what we're going to do is we're going to complete the square. Take half of this one, which would be 3, and square it. Well, when you have an equal sign here, in the beginning, whatever this left side is, it's telling us that this is equal to this. Well, if this was equal to start with, and I just randomly put a plus 9 in here, it's not equal anymore. So what I have to do now is I have to somehow balance this out so that it's still going to be equal to what like it was in the top line. So to do that, let's think about this. If I added 9, what could I do over here at the end that would fix that so that it's still equal to what I had up here? Well, how about we take away 9? Now another way to do that, I'm just going to erase that for a second. Sometimes students will say, well, why don't you add 9 to both sides? And I could, right? I could put a plus 9 here. Right? I've added. Think about an equation. If I had x equaled 4, well, if I add 5 here and I add 5 here, they're still equal. Because essentially, if you then move this 5 over here, we just wipe this 5 out and all would be good. So as long as you do the same thing to both sides, or if you just want to work on one side, and the reason I'm just going to work on one side because I want these to be, if you think of vertex form is y equals, I want it isolated by itself. So rather than add 9 here and then have to move it over here and turn it into a subtract 9, we just think of it this way. If I add 9 here, let me get rid of this stuff. If I add 9 in here to fill my complete the square, I do the opposite here. Take away 9. And now you're ready to go. Y equals, we know how to factor this, you square root of the first, sine of the middle, square root of this one, in brackets squared, positive 4, negative 9, negative 5. Now look what I now know that I didn't know up here. I know the vertex. The vertex of this quadratic is positive 3, negative 5. Remember, it's always the opposite sign in here, same sign out here. There you go. You went from standard to vertex. That's what we're doing on this slide. Here we go again. Y equals, put a bracket, x squared plus 2x. Always a plus sign. Leave a blank. Put your minus 5 back in there. Take half of this number. Half of 2 is 1. Square 1. Remember, don't double it. Square it. Half of 2 is 1. 1 squared is 1. I've added 1 that wasn't there before. That means I'm going to take away 1 at the end so that this line is still equal to the line above. And now we will factor and put it in vertex form. Square root of the first, sine of the middle, square root of this one, all squared, negative 5, negative 1, that's negative 6. Here is now information I didn't have in the top line. The vertex is negative 1 and negative 6. And you can see there's no way to clearly tell that from looking at this. No way to tell from looking at this that that was your vertex. You need to know how to switch it from this form to this form through this process called completing the square. Okay. So that's, again, at its most basic level, how you complete the square. So let's have a look. These will progressively add a few more details. These ones still have a equals 1. So if there's no number out here, that's fine. It's just as easy. You just go y equals, start your bracket, x squared plus 14x, put a plus. There's just nothing here. That's fine. Take half of 14, it's 7. Square it, you get 49. I've added 49. I'm going to take away 49. Put this in vertex form now. Square root of the first, sine of the middle, square root of the last one, all squared. And then you just have a minus 49. Vertex, negative 7, negative 49. All right, one more with a coefficient of 1. So y equals x squared, subtract 8x, always a plus, leave some room, minus 15. Half of 8 is 4. 4 squared is 16. Add 16, take away 16. Factor it down to vertex form. Square root of the first, sine of the middle, square root of this one, all squared, take away 31. Vertex 4, negative 31. Okay, so hopefully those 4 examples kind of give you at least the gist of how the process works. I don't like to throw too many twists at you right away, but certainly they're not all going to work out this easily. So let's have a look at a couple where, and we've looked at it before I get right into working with a quadratic, but in this one, so nothing changes. I got 1 here, that's good. So x squared plus 9x plus. So some of you are probably seeing what the issue is going to be. When I go to take half of this one, it's an odd number, so I'm not going to get a nice integer like I did the last times. So remember, I showed you, don't go to decimals. The only way you go to decimals is if there is decimals in the question. Like if this was 9.2, sure, work with decimals. But if there's no decimals anywhere here, work with fractions. So take half of 9. So I'll just jot. This hopefully is going to be happening in your head, but I'm going to put it up here. Half of 9 is 9 over 2. Square that. Square the numerator, square the denominator. This will become 81 over 4. I've added 81 over 4. I need to subtract 81 over 4. Square root of the first, sine of the middle, square root of this one. Remember, if it's a fraction, you just take the square root of the numerator and the square root of the denominator. So this will be 9 over 2 squared. Now, here you have to do a little bit of fraction work. To add and subtract, you need common denominators. So this is 2 over 1. This one's over 4. Well, 2 over 1 is the same thing as 8 over 4. And again, I'm writing this out, but hopefully you get to the point where you just do it in your head. So there's 8 over 4 is the same as 2 over 1. Take away 81 over 4, so 8 subtract 81 would be negative 73 over 4. So this is just, it's still a quadratic, it just has its vertex situated in a bit uglier location than the last one. Alright, so let's go through this one. Same type of thing's going to happen. So y equals x squared. Take away 3x plus, leave room, minus 10. Half of 3 is 3 over 2. 3 over 2 squared is 9 over 4. I've added 9 over 4 that wasn't there. So I'm going to take away 9 over 4. Put this now in its vertex form. Y equals square root of the first, sine from the middle. Square root of a fraction is the square root of the numerator, square root of the denominator, all squared. Now these, I need a common denominator to subtract them. So 10 over 1 would be 40 over 4. So it's a negative 40 over 4. Take away 9 over 4. Negative 49 over 4. Vertex here would be a 3 over 2, negative 49 over 4. And there you have it. So all of those examples had a coefficient in front of the x squared of a positive 1. Now the last two were a little more challenging because of the fraction work. Usually anytime we have to work with fractions, sometimes students will stumble a little bit on that, but as you get more experience with it, you'll get better at it. So what we want to look at now is what if the number in front is not a 1? How are we going to deal with that? So the first one I've got here is 4x squared, take away 24x. Well, there's an extra step to these questions, and it is this. As we've been doing along, and you're kind of getting the hang of it, it works pretty nice if the coefficient is a 1. Well, we're going to make sure it's a 1. And the way you do that is by using greatest common factor. Any number, doesn't matter what it is, in front of the x squared must get factored out. So you're going to put here 4, bracket. Now you're going to divide the x squared and the x term both by 4. So this is just basically grade 10 greatest common factor. So x squared. The middle term will switch to minus 6x. Now you've got your 1 in front of x squared. We'll just leave the, kind of pretend the 4 is not there for a second. Put our plus sign here. Close our bracket. Now there's no number here this time, so don't have to worry about that. Now just look here for now and do the same thing we did the last 4 examples, or more, however many we've been doing. Take half this one, and square it. Half of 6 is 3, 3 squared. I've added 9. Now, here's the catch. Students in the beginning, they say, okay, take away 9. But this 9, because of where it's situated, is getting multiplied by that coefficient that's out here. So because I've got a plus 9 and a positive 4 out front, what I've really introduced here that wasn't there before, I haven't put 9, I've put 9 times 4, I've added 36. That means I got to take away 36 at the end, not take away 9. Hopefully you see why the difference is this time. All of the ones before, there was nothing out here. So whenever you put a number here, it was just getting multiplied by a 1. But now there's a number here. So whatever you write in here, you got to multiply it by this first, then put the opposite out here. All right, so please make sure you are understanding why that's a 36 or a minus 36 instead of a 9. And now here we go. 4, square root of the first, sine of the middle, square root of this one, all squared, take away 36. So the only difference now is, so your vertex is 3, negative 36. It's just the stretch factor. So this quadratic would be narrower. It would go over 1 and up 4, over 1 and up 4. All right, let's have a look at this one. So y equals, remember what I said, any number in front of the x squared has to get factored out. So in this case, that's going to be a negative 3. X squared, now be careful here, you got to take whatever you pull out as your common factor, you divide this by that number. So 12 divided by negative 3, that would be minus 4x. Put your plus sign, leave room. Now notice you only take the GCF, greatest common factor, out of the x squared and the x term, not the number. Just leave the number. All right? I always tell students here, it's a real good idea to do takes 5 seconds. Check this and make sure that this line is the same as this line. You say, what do you mean by that? Well, take this and multiply it back in here and make sure you get this. Negative 3 times x squared, that's right. A negative 3 multiplied by a negative 4x, there's my plus 12x. I've done it right. A lot of times, the mistake students make in this question is they get the wrong sign here. All right, half of 4 is 2. 2 squared is 4. Now remember, this 4 is getting multiplied by a minus 3. Now you got to be careful here. 4 times a negative 3 is a negative 12. So I need to put something here that's going to wipe out a negative 12. Well, to wipe out a negative 12, I want to add 12. Everyone understand that? 4 times negative 3 is negative 12. So by me putting that blue 4 in there that wasn't there in the line above, it's introduced a negative 12 into the mixture here on the right side. So I need to put a plus 12 at the end so those two wipe each other out. And now we're ready to go to vertex form. Square root of the first, sine from the middle one, square root of this one, which would be 2, squared, 10 and 12 is 22. Opens down, stretch factor of 3 with a vertex of 2, 22. Alright, so that will now get us through any quadratic that's in standard form, and we now see the method to get it to vertex form. So it's just that extra step of factoring out the coefficient. Alright, so let's get rolling here with some more. So these ones, as you can see, are going to be even a bit more difficult because, watch what happens. So y equals, oops. Alright, sorry, a bit of a technical issue there. Seems to be okay again. So let's have a look at this one. So y equals, factor out the 2. Unlike the first couple, it does not go evenly. That's fine, just like we did before. Leave it as a fraction. Don't put decimals in here. So this just becomes 3 over 2 x. Always a plus. Then your plus 8. Half of 3 over 2. Half of 3 over 2 is 3 over 4. Square 3 over 4. 9/16. That number, remember, has to get multiplied by the coefficient. So now I got to figure out, well, what's 9/16 multiplied by 2? Well, it's 18/16, which reduces to 9/8. There's a quick way to get to that. All you can do here is say, well, 2 goes evenly into 16 8 times. You get 9/8. So I've added 9/8. That means I'm going to have to take away here 9/8. Remember, this is 8/1. Alright, here we go. Leave your 2, square root of the first, sine of the middle, square root of this one would be 3/4 squared. Now 8/1, I want it to be over 8, so I'm going to multiply the numerator and denominator both by 8, so that's going to be 64/8. 64 minus 9 would be 55/8. It would be positive 55/8. Leaving us with it opens up stretch factor of 2. The vertex of this one is at a ugly 3/4, comma 55/8. Now that would be very fun to try and sketch, but at least we can algebraically work our way through and find the exact coordinates of that vertex. Alright, let's try one more of these messy ones. So y equals, take out your -5, x squared minus, that's going to actually become positive, right, because it's -15 divided by a -5. So plus 3x plus, we got a plus 9. Alright, half of your coefficient, so half of 3 is 3/2. 3/2 squared is 9/4. That I have to multiply by that. So 9/4 multiplied by -5/1 is -45/4. Put the opposite out here, so I want to add 45/4. Y equals -5. Square root of the first, sine of the middle, square root of this one, squared. Now 9/1. To get that to be over 4, I have to multiply numerator and denominator by 4. So that's going to be 36/4. Positive 36 and a positive 45 will be a positive 81/4. Vertex -3/2, comma 81/4. Stretch factor's 5. It opens down. And there we have standard form changed to vertex form. Now I want you to think about this. For example, if I said to you, what's the y-intercept of this one? So filling in x is 0. If you had this format, you're going to be doing a bunch of calculations and you'd say, oh, well, it's this, that. But if I have this format and say, what's the y-intercept? You instantly say, it's 9. Because 0, 0, that's got to be 9. So that's the one advantage to your standard form, oops, sorry about that, is that you are quickly able to identify the y-intercept. Now, I know that when we get to this point, often students sometimes feel a little bit overwhelmed. It's more by the whole fraction work. Unfortunately, it's going to be part of the life of a pre-calculus student. You need to be able to manage your way through these. So this would be a perfect example of where you may have to rewind and watch these two examples again to see if you get your head wrapped around this, or reach out if you need any further help. But I get that this stuff's getting a little bit more complicated than maybe you're used to running into in your grade 10 and your foundations. Is this my last? Yeah, so I've got this first one. So I got two, this is just two kind of wrap-up examples. So, and these ones are both pretty easy because just 2 or 4. I got 4 of them, sorry. So the first two are really easy because they've got a coefficient of 1 already. So as I said, if you're feeling, and these ones are, none of them are fraction work. So this is kind of where I like to reel students back and say, okay, now don't get overwhelmed with fractions. Here's 4 more examples that you should be able to manage without too much difficulty. There's no fractions going to be involved. And see how you make out with them. So as I said, pause the video. Try these 4 and see if you can get the vertex form. Now, here are the solutions. So y would equal, this one's already got a 1 in front of the x squared, so we're good. Take half of 14, which would be 7, and square it. So I'm going to add 49, which means I got to take away 49 at the end because that 49 wasn't in the line above. Square root of the first, sine of the middle, square root of this one, all squared. The vertex is at 7, negative 49. Y equals x squared plus 6x plus, leave some room. Got my minus 5 this time. Color code again for you. Half of 6 is 3. 3 squared is 9. I've added 9. There's no coefficient, so I'm just adding 9, which means I got to take away 9. Y is equal to square root of the first, sine of the middle, square root of your third, all squared. Take away 14. Vertex, negative 3, negative 14. All right, a couple more with coefficients. So this one's just got a coefficient of negative 1. So we'll take out the negative. It has to be a positive 1 when you complete the square. So this will just switch to x squared. This will switch to take away 2x plus 7. Half of 2 is 1. 1 squared is 1. Now be careful. This plus 1 is really getting multiplied by this negative, which means we're introducing a negative 1 that wasn't there before. That's why I'm going to add 1 here at the end. Go to vertex form. Square root of the first, sine of the middle, square root of that one, all squared. 7 plus 1 is 8. We've got our vertex now here in front of us. It opens down, is all this means. Vertex is at 1, 8. Okay, one final one. This time factor out your 4. So that became an 8. I divided that by 4. I got my plus 1 here. Half of 8 is 4. 4 squared is 16. This number is going to get multiplied by the 4. So I've really introduced here a positive 64, which means I need to subtract 64 at the end. Vertex form. Y equals, leave your 4. Square root of the first, sine from the middle, square root of your last one, all squared. That'll be a negative 63. Vertex at 4, negative 63, opens up with a stretch factor of 4. Alright, so those are some examples that hopefully now have shown you the method that I've referred to as completing the square. And that is the strategy we're going to use to get from standard form to vertex form. Alright, well, best of luck with the video. As I've always said, make sure if you have to rewatch it. If you still can't get something figured out, you need to reach out for some extra help, whether that's through a classmate or through myself via email. I have no problem trying to get you pointed in the right direction. Okay, best of luck, and now it's time to go and find your checkup exercises.